Hello students, in this video we'll see how to use the Laplace transform to solve an initial value problem. Let's consider the non-homogeneous ODE y double prime plus y is e to the negative t, subject to the following two initial conditions. Y of 0 is equal to 0, and y prime of 0 is equal to 0. So I'll solve this by taking the Laplace transform of both sides. So we take the Laplace transform of both sides. So I'll have the Laplace transform of y double prime plus y will be equal to the Laplace transform of e to the negative t. This implies that s squared Laplace transform of y minus s y of 0 minus y prime of 0, that's my Laplace transform of the second derivative, plus the Laplace transform of y is equal to the Laplace transform of e to the negative t, which is 1 over s plus 1. At this point, we can use our initial conditions that y of 0 is 0 and y prime of 0 is 0, and that will mean that both these terms over here will cancel out. So we're left with the following. We're left with s squared plus 1 y tilde of s is equal to 1 over s plus 1, which tells me that y tilde of s is 1 over s plus 1 times s squared plus 1. Now we have two ways that we can invert this Laplace transform. The first thing we can observe is that if I want to take the inverse Laplace transform, y of t will be the convolution of these functions. It'll be e to the negative t convolution. The inverse Laplace transform of 1 over s squared plus 1 is sine. So we can compute our solution by convolution, or we compute our solution by partial fractions. If we do by partial fractions, I will write 1 over s plus 1 times s squared plus 1 as a over s plus 1 plus bs plus c over s squared plus 1, which we can simplify to a s squared plus a plus b s squared plus bs plus cs plus c over s squared plus 1 times s plus 1. So from this we see that a plus b is the coefficient of s squared. So a plus b must be 0. I see that b plus c is the coefficient of s, and that must be 0. So b plus c must be equal to 0. And finally, a plus c must be equal to 1. a plus c must be equal to 1. So we can take the first two equations and subtract them. If I subtract the first two equations, that will tell me that a minus c is equal to 0. So a is equal to c, and if a plus c is equal to 1, they both must be equal to 1/2. If a and c are equal to 1/2, this is going to force b to be negative 1/2. And we can check that all these conditions are satisfied. 1/2 minus 1/2 is 0, 1/2, negative 1/2 plus 1/2 is 0, and 1/2 plus 1/2 is equal to 1. So we see that our Laplace transform, y tilde of s, is really a, which is 1/2, over s plus 1. And then I have plus 1/2 as a common factor of both. And my b is, I'll have a negative s, and then a plus 1 over s squared plus 1. And from this we can simply do the inverse transform. We have that y of t, the inverse transform of 1/2 over s plus 1 is 1/2 e to the negative t. And then I have a 1/2. The inverse transform of 1 over s squared plus 1 is equal to sine, so that's going to be a sine of t. And then negative s over s squared plus 1 comes from negative cosine. So I'll have a negative cosine of t, and this is the solution of my initial value problem. If we were to compute the convolution of e to the negative t sine t, we'll arrive at this answer. And that's a good exercise to do to verify that both methods are equivalent. Thank you very much.